Hello everyone. In this video we are going to solve the very basic questions of definite integrals. Children, as you know that we are bounded with two limits in definite integrals, that is your lower limit and your upper limit. Here in definite integral you will be getting your answer in numeric form. So let's see how we can solve these questions. First of all, this is the question given. I will be simply breaking this function into two by writing it like this, 1 dx. This is known as your lower limit and this is known as your upper limit. Children, you have to simply integrate it. So integration of x is x squared by 2, but then you have to show these limits also over here. Plus again integration of 1 dx is just x, but then you need to put these limits over here. Now children, what you have to do, in the place of x, first of all you will put in your upper limit, then you will be putting minus sign in between, and then you will be putting your lower limit. So this will be upper limit, that means 1 square by 2 minus 1 square by 2. So what I have done, upper limit minus lower limit. Similarly here also, in place of x write down the upper limit, and then in place of x you write down again the lower limit. So this is upper limit minus lower limit. Now you simplify it, you will get your answer. So this is just 1 by 2 and this is again 1 by 2 plus this will be 1 plus 1. So you will be getting here as 2. So the answer of integration of x plus 1 with respect to x from minus 1 to 1 is 2. Let's see the next question, children. Here it is given sine 2x. So you know integration of sine 2x will be minus cos 2x upon 2. But then you will be writing this 0 to minus 4. 0 to minus 4, where this is your upper limit and this is your lower limit. You can write this minus sign outside also. So let's suppose I am writing it as minus and then I am putting the values. So this is cos 2 into x, that means upper limit is pi by 4, minus again you will be putting the lower limit. So cos 2 into 0, and this half is a constant, so let's suppose I am taking this half out. Alright, so here I am getting minus half, this is just converted into cos pi by 2 minus cos 0. Now you just write down the values of cos pi by 2. So cos pi by 2, you know it is 0, minus cos 0 is 1. So you will get it as half, just half. Let's see the third question, children. Here it is given to you as integration of e raised to power x from 4 to 5. So what you will be doing, you will just be integrating this. So integration of e raised to power x is e raised to power x, and then you will be putting these limits over here. Now simply put the upper limit minus lower limit. Now e raised to power 4 you can take out common, and here you are left with e minus 1. So this is the way we get our answer in definite integral. Let's see these questions, children. Here it is given in the form of, this is actually in the form of integration of x square minus a square form. So this is a particular function case, and the formula for this is 1 by 2a log of x minus a upon x plus a. In place of a you are having 1 over here, so you will be writing 1. So since we know that integration of this with respect to x is this, so we will be applying this formula in the given question. So you will get it as 1 by 2 log of x minus 1 upon x plus 1, but then you have to put the limits also, 2 to 3. Now this half is a constant value, so it will be like this. Now you will be applying this upper limit, so it will be log of 3 minus 1 upon 3 plus 1 minus upper limit, and then you will be writing lower limit. So lower limit will be 2 minus 1 upon 2 plus 1. So on simplifying it, you will get half log of 2 by 4 minus log 1 by 3. Here I can cancel it. So I will be getting it as half log of half minus log of 1 by 3. Now children, you know by the property of log, if it is written log m minus log n, then this can be written as half log of 1 by 2 upon 1 by 3, which will give you as half log of 3 by 2. So this is your final answer. See the next question children. Here it is given 2x plus 3 upon 5x square plus 1. So I can break it into two functions as 2x upon 5x square plus 1 dx plus again 0 to 1 3 by 5x square plus 1 dx. Now children, here I will be applying substitution method. But you see, if I take this as x or this as another variable t, then the differentiation of this should be present in the numerator. That means if I am taking let 5x square plus 1 equal to t, then I am getting the differentiation as this. But here I am having just 2x. That means if I multiply and divide this by 5, then my purpose will be solved. Children, one more thing here you have to take note of it. Whenever you are applying substitution method, then you have to always change the limits according to the things you have supposed. So if your x tends to 0, then your t will tend to what? So you will be taking it like this. If your x tends to 0, then your t will be, if x equal to 0, then t will be equal to what? It will be 1. If your x is equal to 1, then your t will be 5 plus 1, that is 6. That means whenever you are going for substitution method, you have to always change the limits. So first of all, to get this, I am multiplying and dividing. I am multiplying and dividing it by 5. Alright. So this, in place of this 10x dx, I am writing just dt. This 5 I am writing out integration. Now here the integration would be from 1 to 6, and this I have considered as t. Okay, plus now look here children, if I have taken this as t, or simply this can be reduced to your a square plus x square plus a square form. That means here I can write it as 3, since I need to get my coefficient of x square as 1. So I will be taking 5 common out of it. So I am writing 5 over here, and I am getting x square plus 1 by 5. And if I want to make it a perfect square, then I will be writing it as under root whole square. Now this is the formula for x square plus a square. 1 upon x square plus a square is 1 upon a, 10 inverse x by a. So here I will just be doing the integration 1 by 5. This is log of t, and I will be writing it as from 1 to 6 plus 1 by 5 we have already here, and now I will be writing 1 by a. So what is my 1 by a? 1 by a. So this is my 1 by a. 10 inverse x by a. X by a, that means this. Okay, these are the constant terms, so they can be written out, and here I will be writing it as, it was going from 0 to 1. So from 0 to 1. Alright. So here I am getting it as 1 by 5 log of 6 minus log of 1, and here you will be getting it as 1 by 5 under root 5, 10 inverse root 5x. I have not put the limits in the next case. Now I will be putting it. So this is log of m minus log of n, which can simply be written as 6 by 1 or simply as 6 plus 1 by 5 root 5, and here it will be 10 inverse root 5 upper limit, that is 1, so it will be this, and 10 inverse 0. So this is the answer I am getting. Write the value of 10 inverse 0 as 0, and the rest part will be your answer. Have a look. We missed this 3 children, it is 3 over here, so 3, it is 3, it is 3. See this question children here. We can again separate into two functions, that is from 0 to 1 x into e raised to power x dx plus 0 to 1 sine pi by 4 x dx. Alright, now children, you can see that here we are having product of two functions. Whenever we get product of two functions, then we have to apply integration by parts method. That means I have to select first of all which is my first function and which is my second function. And for that I have told you that you can select your function by the simple word ILIT. So I am having here algebraic function first and exponential function second. So this will be considered as u and this will be considered as v. Now how you are going to integrate it? See, here you will be writing it as the formula for integration by parts is first term as it is. So first term as it is, integration of e raised to power x, integration of e raised to power x, and then you will be writing these limits over here, minus whole integration differentiation of first function, that is x, again integration of second function, that is e raised to power x, and then I will be again doing the integration. Alright, and for this next part what I will be doing, simply sine pi by 4x integration, I know it is minus cos pi by 4x, and since this is again a function, so pi by 4 will come down. Alright, so here I have integrated it from 0 to 1. Now look children, this will be x e raised to power integration, e raised to power x integration is just e raised to power x, 0 to 1 minus differentiation of x is just 1. So I will be getting integration of e raised to power x, which will be just e raised to power x dx. I have integrated over here and I have written the whole integration, that means from 0 to 1, minus here I can put the values cos pi by 4, or this is 4 pi which can be taken out, this is a constant term. Here in place of x, once you will write 1 minus cos pi by 4 into 0, so which will turn out to be a 0. Now you look here, here I can write it as 1 into e raised to power 1 minus 0 into e raised to power 0. So this is upper limit minus lower limit. Now again you have to integrate it. So integrate it with respect to x, it will be just e raised to power x, and here your limits are 0 to 1, minus 4 by pi, you know cos pi by 4 is 1 by root 2, and minus cos 0 is 1. So I will be writing it as 1. Now here it is given to you e raised to power 1 minus e raised to power 0 is 1, you know, minus, again we have to put the value, so it will be e raised to power 1 minus that minus, and this minus will make it e raised to power 0, minus 4 by pi, and here I am getting it as 1 by root 2 into minus 1. So here this e raised to power minus 1 and e raised to power minus 1 gone, and here e raised to power 0 is again 1, so this and this is again gone. So I am just getting it as 4 pi 1 by root 2 minus 1. Or if you want to rationalize and if you want to solve it, then you can solve it further. Sorry children, we have mistaken here, it was 0 into this, so it will become just 0. So this term will get vanished, and here I will be getting it as e raised to power 0, I will get it as 1. So here I will get it as 1. Now this is your final answer, or you can simplify it further.